Alright, so the first problem is a classic physics problem where you have an object on an incline. In this case, it is incline about 20 degrees angle. And you have an object here that's going to be experiencing a couple of forces on it. So in the problem, it says that there's going to be a force applied. So a person is pushing up on it. And there's going to be force of gravity. And because of gravity, there's going to be a force normal. And then there's also going to be force of friction, which will be against force applied. I know it's kinetic friction because it says constant speed up here. This is kind of important for a couple of reasons. One, I know it's moving, so I know it's kinetic, so I don't have to worry about static friction. And the other thing is I know that in the x direction, which I'm going to redefine, it's going to be sum of all forces is going to be 0. So in a problem like this, it's advantageous to define your x and y axis similar to the most forces that you have. These are kind of all on the slant or on the incline, where f of g is the only one on our traditional x and y, straight up and down. But since there's only one, it makes more sense to make this our new y and make this our new x. And the reason is because here I have 1, 2, 3 forces that correspond with this or plane, where this one's not. So I only have to change these into the f of g into its components and not have to change 1, 2, 3 of them in its components. So it makes life a little bit easier. So because of that, I'm going to change my components. So I probably should have done different colors. So let me see if I could overwrite these. So let's say the reds are the x's. And then we'll keep green as y. So, and I'll just do green here. So this will be f at g at y. And then this will be f at g at x. So by doing that, now I have two forces that are in the same plane as this. So f of g is going to correspond to Fn, f of g at x is correspond to force applied up, and force of kinetic friction down. Now you have the setup. So the main question is, what are all the forces? So we want to be able to define each of these forces by just looking at the problem itself. And we could do it by starting off with the thing that's easiest known, or the thing that's the known fact, which is this one. And it's because I have 75 kilograms. Because of that, I could find f of g. F of g, remember, is just mg. So I can plug it in. Mass is 75 kilograms times 10, so f of g is 750 newtons. I'm not going to worry about the sign right now, but that's what it is. I want to figure out now, if I have f of g, I can figure out both of these. This angle right here is the same as this one angle right there, so I can figure out fgy and fgx. These are kind of the formulas that you are given. So fg at x, let me change the color. Ooh, I thought I erased everything. Let's change the color. Let me just erase it the traditional way. FGX is red, so let me do that. F at g in the x direction is equal to FG sine theta. So that's 750 sine of 20 degrees. So let me find my calculator. $750 sine of 20 gives me about 256.5 newtons. I'm going to do the same thing with FGY. FG cosine theta. So in this case, it's 750 cosine of 20. Seven 04.7, so I'll just put 0.8 newtons. All right, so those are my two. Now, once I have that, I can figure out a couple things. The first thing I want to figure out is both the sum of all forces in the y direction, and then I want to do sum of all forces in the x. I like to do y first just because it's easier. Most of these problems, it's not going to move up or down in the y direction. The refrigerator is not going to float up, and the refrigerator is not going to go into the floor. So in most of these cases, sum of all forces in the y is equal to 0 because the acceleration is 0. And now the two forces that are here is force normal plus force of gravity in the y. So 0 is equal to force normal and then FGY, which is 704.8 newtons. Now, this is when you do want to make up a sign. Do you want to assign a negative sign to FGY? If you do, then Fn is going to be positive. If you assign positive to FGY, then Fn is going to be the opposite. So whatever you choose, Fn is just going to be the opposite of F. Since it's kind of down, I'm going to make it negative. So Fn in this case is equal to 704.8 newtons. So I got one of my unknowns, Fn. Now I'm going to go to try to figure out what these are. Sum of all forces in X, I have 1, 2, 3 forces, Fa, Fgx, and then F(kf). So I'm going to define it based on what it is. So I don't know what Fa is. I do know what Fgx is, and I can figure out what force of kinetic friction. You have to determine which way you want it to be positive or negative. Left to be positive or right. I like going right to be positive, so I'm going to make this one negative. So sum of all forces is equal to Fa, which is the unknown. Fgx is up here, so I'm going to make it negative 256.5. And then I can figure out this one. This is the same direction of Fgx. I'm going to make it negative. And force of kinetic friction is mu k Fn. And luckily for us, we have Fn over here. So then here, this is also equal to 0 because of the constant speed. So remember, sum of all forces is ma. A in this case is 0 because it's constant. So 0 is equal to Fa, force applied, minus 256.5 minus mu, which is in this case 0.2, times 704.8. Plug that into my calculator. 0.2 times 704.8. I get 140.96. These are both negative. 256.5. So I get 0 equals force applied minus 397.46. Move it to the other side. Force applied is equal to 397 points. I'm just going to round it off, 5 newtons. So I have all the unknowns now. So I found out here is, I didn't do it, but this is force of kinetic friction, which I should have done on its own. Here's force normal, here's force applied, and then here is force of gravity, and I think that's it. So in these kind of problems, you break it apart into its x components and its y components. If it's at constant speed, both the y and the x are going to be 0, where the sum of all forces is going to be 0. And then by knowing that, you could kind of figure out the different forces that are there. And in this case, the unknown is Fa, and the initial one was Fn. All right, for the next problem, we have something a little bit more complicated. We have a pulley system right here. And with the pulley, it looks more complicated, but just remember, a pulley just changes the direction of the force. So here is our situation. We have a man trying to climb up a slope. It is tied to him. A rope is tied to him, which is then tied to a mast that is hanging down. So we want to kind of figure out what's going on here. So this mast is only experiencing two forces, force of gravity and force of tension. And the big deal here is that it's at constant speed. And if it's at constant speed, then we know that sum of all forces is equal to 0. That means everything is equal in the opposite to each other. It's kind of hard to imagine, but just remember, even if it's constant speed, it could be moving, but the forces are still equal to each other. We know that this block has a mass of 30 kilograms, and just like that, I already know what Fg is, which is 300 times 10. And because I know it's at a constant speed, I know this tension is also 300. Just because, remember, if I'm just focusing on the block itself, it has force of gravity, it has force of tension. Sum of all forces in just the block is T plus Fg. Since this is equal to 0, T plus 300 will equal 0. So if you move it to the other side, T is just equal and opposite to whatever Fg is. So in this case, I left it positive, so T will be negative. But if I made this negative, then T will become positive. So it's up to you. Tension pulls the same on both sides, so that means the tension here is 300, but it's going to be opposite direction. And then the man right here is experiencing a few forces. Is experiencing force of gravity on him, and that is 90 times 10, so 900 newtons. But you'll notice that this force of gravity is straight down while he's going up an incline. So technically, you could break apart this into force of gravity in the y direction and force of gravity in the x direction. Force of gravity in the y direction will correspond with force normal, and then force of gravity in this side is going to be pulling down on him as well. So then, in order for this to balance out, he or she has to push up with force applied. In this case, it's this is force applied. Technically, it's also static friction, and I'll kind of explain why. In a problem like this, we could ignore friction because you're not sliding and you're not still. And it's kind of weird to think of that, but the only reason that this person could push against or at least climb up or pull up this block up a hill is because there's friction between their shoe and the ground. If there was no traction between the shoe and the ground, the person is just going to slide down, which is the second part of the problem. So in this case, you could think of force applied as static friction or just think of it as force applied. We're not calculating mu, so we don't really have to find out. But that's kind of what's going on. Like force applied is the static friction between him and that, but it doesn't have to be max. It's just what it is. So I'm just going to call it force applied because it makes more sense in my head. But I think those of you who kind of really need what happened to friction, it's there. It's just part of the force applied. All right. So the goal is to try to figure out all these different forces by just kind of deducing out. We kind of figured out quite a few, right? We already figured out this one and this one. I can't assume FA is 300 because FA also has to fight against gravity. So we need to find both FGY and FGX. So I'm going to just plug that into my calculator. FGX is equal to FG sine theta, and then FGY is equal to FG cosine theta. So FG is 900. Sine of 30 degrees. So that gives me 450. 900 cosine of 30 gives me 779.4. So I'll just call it 779 newtons. So those are my two. So FGY is 779 newtons. Remember, it's not moving up or down. So if I want to be more formal, I could say the sum of all forces in the y direction is Fn plus force of gravity in the y. This is equal to 0. So Fn is equal to negative, or 0 is equal to Fn minus 779. And then you just move it to the other side. So Fn is equal to 779 newtons. Okay, so that one's easy. FGX will help us figure out what the FA is. So FGX is negative 450. So sum of all forces on the man or person. Oh, man. Sum of all forces on the man is this yellow tension. So with tension, then you have force applied, and then you have force of gravity in the x. So right here. So let's plug it in. Tension is 300. FA is the unknown. FGX is 450. Now you have to make a decision. Which ones you want to make positive, which ones you want to make negative. For me, it makes sense to make FGX and tension negative. So if that's true, this adds up. Remember, this is still 0 because of constant speed. So 0 equals negative 750. Yep, plus FA. Move it over. FA is equal to 750 newtons. Okay, so there is all my forces if he was going up at a constant speed. Now the second part of the problem, now he falls and slides down, and here's your acceleration. I didn't write it down, but it says down the slope. So down the slope. So now you have the person sliding this way. It's attached to the mass and it's going down. So we want to figure out what is mu. So if we have that, we still have pretty much the same kind of forces. So let me kind of redraw it so it's a little bit better. Let me try to find some room. I'll do it right here. So you have, I'm going to draw a block for the man sliding down at A is equal to 1.5 meters per second. So you have tension that's this way. You have FGX, which is this way. You have you have force of friction, which is this way because it's sliding down. Friction is going to be the opposite. Let me just make sure that's it. That's it. And then you have the weight right here, which has tension, and then force of gravity. Now, you have two choices here. I'm going to use the whole system in this problem. And the reason why I want to use the whole system, if I do the whole system, what's nice is that these tensions cancel out. Even though I knew the tension over here, which is 300, it's no longer 300 right here because you have acceleration now. Before, it was constant speed, but now you have acceleration. These tensions are no longer 300. So if I want to solve with just focusing on the person, which is possible, I need to solve for tension first and then come back to it. For me, I think it's easier just to look at the whole system and kind of just, okay, let's just look at the whole system. The only force I have to add is technically Fg, which I already know, which is in this case 300. So if I look at the whole system, we have sum of all forces in the whole system. I have Fg here, tension, Fgx, and then force of kinetic friction. And what's nice here is wherever I make it negative or positive, the tension is going to cancel out because one is up and one is down. So whichever way you kind of determine negative to be, it's going to cancel out. Let's say this down is negative. So let's say this is, I want to make this negative and this positive. That means my acceleration is negative. This is negative. This becomes positive. This is negative. This is positive. And this is negative. So I'm going to label it now. Fg I labeled as negative, so negative 300. This T is positive. This T is negative. Fgx I labeled as negative, so that will be 450. And Kf I labeled as positive, and that would be, oh, I erased it. Did I erase it? I never found it. Okay. Kf will be, oh, what we're looking for, force of kinetic friction. Okay, so here this is cancel out. Here's 450, and then we know this is ma. So we can't forget that this is no longer 0 because now we have acceleration. M is going to be of both masses, so the 90 kilogram person and the 30 kilogram block. So that will be 90 plus 30. Acceleration is negative 1.5 equals negative 300 minus 450 plus force of kinetic friction. I'm just going to solve for this. 90 plus 30 is 120. Hopefully I did my math right in my answers. Times 1.5. So I get negative 180 plus 750. So force of kinetic friction. Oh, did I do that right? That should be wrong. Let me see. 90. I did it wrong. 90. Sorry. 120 times 1.5 minus 570. Okay, force of kinetic friction is equal to 570. Remember that's equal to mu Fn, and Fn is, let's see, did we ever find Fn? Oh yeah, 779. So if I solve for that, mu is equal to, That seems kind of high. 570 divided by 779. Huh. Mu is equal to 0.73. That seems kind of high. I don't remember it that high. Let me check my answers. FG. FGX. Okay. All right. I think that's it. Let me check my answers that I posted. See if I'm even close. Oh yeah, 7.3. It just seems kind of high to me, but that's the correct answer. So hopefully that makes sense. Let me know through email if you need any help.